create Docker images and how to work with Docker containers, how to deploy our application inside the Docker container, how to write Docker file. In order to execute your application in the Docker, you need to create one Docker file for that. Then Docker registry. Docker registry is a place where we are going to store Docker images of our application. Then Docker Compose, it is advanced than Docker here. Docker Compose is used to work with multiple containers for our application, and how to set up our projects by using Docker. So basically, how to run one Java based application by using Docker, how to run Spring Boot application by using Docker, and even we can see how to run a Python application also by using Docker. Then we will see the conclusion for this one. Okay, good. So this is the agenda for today and tomorrow. What is Docker? Why Docker? Docker setup, Docker architecture, Docker images, Docker containers, Docker file, Docker registry, Docker compose, and how to execute our projects by using Docker. So this is what we are going to learn for these 2 days of time. Good. So first guys, if we see what is Docker. So Docker is called as a containerization software. If anyone asks you what is Docker, we need to tell that Docker is a containerization software which is used to simplify our project execution in any computer. Docker is a containerization software. It is used to simplify our project execution in any type of computer. Nowadays in the market, people are developing the projects by using microservices architecture. So in one project, multiple microservices will be available. Every microservice will be executed as a Docker container. In the real time, application execution will happen using Docker containers only. Sir, when the Docker was not available, there are some challenges in the project execution process. Docker simplified the execution process. So why we need to go for this Docker? What is the benefit we are going to get with the Docker? Let's understand right now. So we are going to see one application architecture. If you see, for every application, front end will be available. Application will contain backend also, and application will contain one database also. So for every project, these are common. So front end will be available. This front end we are going to develop by using some technologies, and project will contain backend also. Backend will be developed by using some other technologies, and we are going to use database for our application. This is a common architecture if you go to any project. This front end will communicate with the backend. Backend is going to communicate with the database. Right. Now here, what database we are going to use for the application? Some people will go with the Oracle database. Some people will go with the MySQL database. So database server is required for our application. Coming to the backend, some people will develop a backend with Java. Some people will develop with Python. Some people will develop with .NET. Coming to front end of the application, people will be developing this by using Angular. Some projects will use React.js, right? This is technology stack that people are going to use in the industry as part of our application development. Front end, back end, and database. Now assume that for our project, development team is available. Multiple developers will be available in the team. So those developers, some people are working on front end of the application. Some people working on back end of the application. Some people are working on database of the application. Now, project coding is completed. Front-end team developed UI part of the application by using Angular. Back-end team developed the business logic of the application by using Java. And we are using Oracle database for our application. Once the coding is completed, can we deliver this code to the client directly? Whatever the coding is completed, are we going to deliver this code to the client directly? No. we need to test our code. We need to test our code. So in the team, multiple people are available. Every developer is having their own laptop. The system, Office is provided one system to write the code. They completed the coding part and they committed their code into GitHub repository. Whatever the code they implemented, code is available in the GitHub. This person is having one laptop. Company provided laptops are available. They completed their code. Once their code is completed, all the developers code will be stored inside one repository, which is called GitHub repository or Bitbucket repository will be available. All the developers are going to store their code into GitHub repository. Once the code is available in the GitHub repository, that code should be deployed into server. That code should be deployed into server. Let's assume that I'm taking one server which is called dev server. Dev server nothing but developers are going to use this server to test that the application code is working as expected or not. So I developed some front-end functionality, you developed some back-end functionality, they developed some other back-end functionality. Now all the developers code is integrated in the GitHub repository. Now we need to deploy the final code of our application into one server to test that code is working as expected or not. Now I have taken one server. That means I have taken one machine. I have taken one machine. In this machine, I want to deploy my application. In this machine, I want to deploy my application. So this machine is called as a dev server machine. Why I am calling as a dev server machine? Developers are going to use this machine to test their code is working as expected or not. My code is working or not, your code is working or not, her code is working or not, because we developed independently. I am working in Hyderabad, I developed login functionality. You are working in Bangalore, you developed some admin functionality. They developed some registration functionality. Some other member developed reports functionality. All the developers code finally integrated in the GitHub. Now we need to test a complete functionality. So when the code is integrated, we will deploy that code into dev server and we are going to test that code is working as expected or not. Here there is a problem. The problem is, if I want to deploy my code in the dev server, in this server we need to install Angular software. Why? Because my project front end is developed by using Angular. My project front end developed by using Angular. Angular should be installed in this machine. So Angular software should be installed in our machine. Along with this Angular, Java software should be installed, which is used for the backend development. And my project is communicating with the MySQL database. MySQL database server should be installed. For my application, Tomcat server is required, like this. So these are called as dependencies to run our application. These are called dependencies which are required to run our application. Code is available. Developers has done the coding. Code is available in the GitHub. Now that code should be deployed into one machine to test. Is it working as expected or not? This deployment process will be taken care by operations team. That is called DevOps team. DevOps team will be available in the project. That DevOps team is going to take the code from the GitHub. They want to deploy that code into one server. So directly they can deploy the code. They need to install some softwares also to run that code. They need to install some softwares. My code is developed by using Java. For that, Java software should be installed. My code is communicating with MySQL database. That MySQL database should be installed in that machine. My front end is developed by using Angular. Angular software should be installed in that machine. If all these softwares are installed properly, then only our application can execute. Are you getting my point? So the softwares which are required to run our application, these softwares are called dependencies of the application. Without these dependencies, our application cannot be executed. Are you able to follow this? Okay, the DevOps engineer taken one machine, he installed all the required softwares properly. Application is deployed. We have tested. It is working. The code is working as expected in the dev environment also. Once the dev environment deployment is completed, same code we need to deploy in the another environment, which is called SIT environment. Software testing team is going to test our application in the SIT environment. If I want to deploy this code again in the another machine, dev machine is separate, SIT machine is separate. Dev machine will be used by developers for testing. Once developers testing is completed, this application should be deployed into SIT server. When I say server, it is a machine, guys. In the real time, when we call server, this is one machine. SIT server is available. SIT server will be used by testing team to test the application. You got my point? Now, if I want to run this application in the SIT server, again, what is required? Angular should be installed, Java should be installed, MySQL should be installed. Now, this code is working in the dev environment. Whenever we deploy this application in the SIT environment, it is not working. The code which worked in the dev environment, same code is not working in the SIT environment. The reason, our code is developed by using Java 17 version. By mistake, this DevOps engineer installed Java 11 version in this machine. Actually, my application requires Java 17 version, but the DevOps person is a new person in the team. He installed Java 11 version in the SIT system. With that Java 11 version, compatibility issue is there. My code is not working. Are you getting my point? When the code is not working in the SIT environment, what testers will do? They will say that application code is not working. Developer has not done the development properly. They will raise a complaint in the Jira. They will raise a bug in the Jira. But actually here, is it a coding issue? Is it an environment issue? It is a environment issue. The environment is not prepared properly to run our application. Who will prepare the environment for our application execution? Developers or DevOps people? DevOps people will prepare the environment to run our application. So we need Java 17. By mistake, they have installed Java 11. So our code is not working as expected in the SIT environment. Are you guys able to follow this? These are called as environmental issues. In the real time, these kind of issues are called environmental issues. Now, in the SIT, they have done the mistake, then they have corrected. After SIT completed, our project should be deployed into one more environment called UAT environment. In the UAT environment, client is going to test our application. So if I want to deploy my application in the client environment, again what I need to do? I need to install Angular, I need to install Java, I need to install MySQL. If these softwares are installed properly, then only my code can be deployed in the environment. Then only my code can be deployed in the environment. After this UAT environment, then my code will go to production environment. Production environment is nothing but live environment. In the live server, my code should be deployed. Again, I need to install Angular, I need to install Java, and I need to install MySQL in order to execute my application. So in the real time, for every application, we are going to use dev environment, and we will use SIT environment, and UAT environment will be available. In some projects, pilot environment will be available, and prod environment will be available. Who will use this dev environment? Developers. Dev environment for developers integration testing. All the developers code is integrated. Once the code is integrated, all the functionalities are working as expected or not, we are going to test in the dev environment. So to deploy our application in the dev environment, all the softwares should be installed properly, then only code can execute. If they don't install the software properly, our code execution is going to fail. Our code execution will fail if softwares are not installed properly. The software's installation only in one system, or it should be installed in all the systems. Wherever you want to test your application, in all the systems you need to install the softwares. Okay, now here dev environment is there, SIT environment for testers testing, for testers integration testing. Software testers are going to test our application. For them, SIT environment will be available. So in the SIT environment also, we need to install all the required softwares again. We need to install the softwares in the SIT environment also. For example, by mistake they installed Java 11 version. Then what will happen? Code can execute or code cannot execute? Code cannot execute. Is it coding problem or is it infrastructure problem? That is called environment problem. Once the SIT deployment is completed, UAT for client acceptance testing. UAT stands for user acceptance testing. For which client we developed this application, before giving the delivery, client is going to test our application. For that, again, separate environment will be available, which is called UAT environment. Here also, we need to install all the required softwares. Once UAT completed, pilot environment will be available. Pilot is called pre-prod environment. Before giving the live environment, before going for the live, application will be tested in the pre-production environment. Once it is completed, finally, application will go to prod environment. Prod environment is called as a live environment. End user can access the application when it is deployed in the production environment. Now, if you see, there are 5 environments available. In a company, in the project, some projects may have 10 environments also. Suppose if 10 environments are available, then what is the problem? If 10 environments available, then what is the problem? Dependencies are the problem. Installing all the required softwares, installing the particular version of the software is a difficult task for the operations team. It is a difficult task for operations team. So to avoid these kind of environmental issues, we are going for Docker. Why we are going for the Docker? To avoid this kind of environmental issues, we are going for Docker. Sir, what is the use of Docker here? When you go for the Docker, if you want to run your application in any system, if you want to run any application in any system, instead of you are installing the Docker, instead of you are installing the dependencies, you install a Docker in the system. You install the Docker in the system, or you use the Docker software in the project. If you use Docker software in the project, what are the dependencies available for the application? We no need to install those dependencies. We no need to install those softwares in the machine to run our application. Docker will install the softwares to run our application. Are you guys getting my point? I have a brand new computer. In this, just now I purchased this computer. No Java, no database, nothing is available. I want to run Java application. By using Docker, I can run that. If I use a Docker, Docker will install Java. Docker can install Python. Docker can install database. Docker can install Tomcat server also. Whatever the softwares which are required to run our application, instead of we are installing, we will tell to Docker to install the softwares and run the application. That concept is called containerization. That software is called containerization. If you see the Docker logo, ship will be available. Inside the ship, some boxes are available. Those boxes are containers. Inside the container, application will be available. For every application, one box will be created. That box is called container. Inside that container, softwares will be available. Our code will be available. We are going to package our code plus required softwares as one container. That is called containerization. Why the ship is available? By using these Docker containers, we can run our application in any system. Easily we can transfer, easily we can ship our application code to any machine for the execution. That's why in the ship they kept the containers. That means your containers can be transferred to any location. Your containers can be executed in the any system. That is called containerization concept. So what is the benefit with the containerization? Come on. What is the benefit with the containers now? You no need to bother about the dependencies to run your application. So guys, dependencies means don't go to Spring dependency. Those are called libraries now. So when we are talking about only Java, Spring Core dependency, Spring MVC dependency will be available. When we are talking about the Docker, the Spring Core, Spring MVC, those are called libraries. Java, MySQL, Tomcat, these are called dependencies. The required softwares to run our application are called as dependencies. So if you want to run the project, libraries are required, dependencies are required, and code is required. Now you see the diagram. If you want to run your application, for example, for my application, I'm writing some code. For my application, I'm writing some code. So this code I'm going to develop by using Spring Boot. I'm going to develop this by using Spring Boot. And I'm using Spring Security. I'm using Data JPA. Data JPA. I'm using JUnit. I'm using Redis. What are these called now? What are these called now? These are called libraries, jar files. These jars I want to use in the code. Who will download these jars required for our code? Maven. So you no need to download these libraries. So these are called libraries to run our application. Are we downloading the libraries manually? No. Who is downloading the libraries for our application? There is a tool called Maven. For my project development, I need a Spring Boot, I need a security, I need a JPA, JUnit, Redis is required. These are called libraries required for the application. These libraries will be downloaded by Maven software. Now, so this is developed by using Java. Only libraries are not sufficient to execute the code. In my computer, I should have a computer. In my computer, one operating system is required. Okay. And I need to install Java software, and I need to install Angular software, and I need to install MySQL server. So these are called dependencies. These are called libraries. Okay. So to develop the code, libraries are required. So as a developer, you will install Java in your system. You will install MySQL server. You will write the code. You will test the code. But when you go to environment, when your code is deploying in the dev environment, it is a new machine. In that, no Java, no Angular, no MySQL, no operating system. Okay. Now, here, if you want to run this application, libraries are required and dependencies are required. Libraries are required and dependencies also required in order to run our application. Libraries will be taken care by Maven. Libraries will be taken care by Maven. Dependencies will be taken care by Docker. Are you guys getting my point? So this Maven and Docker tools are very, very, very important when we are running the application in the real time. So we are developing the application by downloading the libraries by using Maven. Now development is completed. I want to deploy the application. Deployment will happen only in one system, or deployment will happen in the multiple systems? Multiple system. Dev systems will be available, SIT systems will be available, UAT systems will be available, pre-prod, prod. So minimum to minimum 40 to 50 systems will be available to run our application in the real time. Coding we are doing in one system, but deployment will happen in the 30 to 40 systems in the real time. When I want to deploy my application in the 30 to 40 systems, in all those systems, operating system should be installed. Windows or Linux. Java should be installed. Angular should be installed. Database should be installed. That is difficult in the real time. Okay. In 40 systems, I installed Java 11 version. I installed Java 11 version. After 6 months, client told that upgrade to Java 17. Then what we need to do? Again, we need to go to all the 50 systems, uninstall the Java 11 and install the Java 17. So by mistake, the DevOps engineer is a fresher. Instead of Java 17, he installed Java 14. Then the code which is working in one system is not working in the another system. This is very common problem in the real time. The code which is working in my local is not working in the SIT. The code which worked in the SIT is not working in the production. It is not because of the coding problem. It is because of the dependencies problem. It is because of dependencies problem. Who will take care of those dependencies for the project? Who will take care of the libraries? Libraries will be taken care by developer. Dependencies will be taken care by DevOps people. So it is difficult to maintain all the dependencies correctly in all the systems to run our application. To avoid that problem, we are using Docker in the project. To avoid that problem, we are using Docker in the project. What is the benefit if I use Docker in the project? What is the benefit I am going to get if I use Docker in the project? Docker will download the dependencies to execute our code. Maven will download the libraries. Docker will download the dependencies to run our application. The process of executing our application using Docker is called containerization. What is that, guys? Executing our application with the help of Docker is called containerization. So in the real time, every microservice will be containerized. Every microservice will execute inside a Docker container. Container means one box. What will be there in that box? Libraries will be available, code will be available, dependencies will be available. Who will download the libraries? Maven. Who will download the dependencies? Docker. Code will be available. Code, libraries, dependencies will be packaged in the box for the execution. That box is called container. The process of executing our application by using Docker is called containerization. Are you able to follow this? Now, you read the definition for the Docker. Now you will understand. Can you see what is this one? Docker is an open source platform for developing, shipping, and running applications in the containers. For development, for shipping, for running our applications, we are going to use this Docker. Containers are lightweight, isolated environment that package applications and their dependencies. So which computer you are using, what operating system you are using, that's not important. Docker will take care of the dependencies required for our application execution. Benefit of using Docker. Can you read? What is the benefit of using Docker? Portability is available, scalability available, consistency available, and efficiency is also available. Yes, guys, theoretically, you got the clarity. Why we need to go for Docker? Why we need to go for Docker? To execute our application as a container. Why we need to execute our application as a container? Why we need to execute our application as a container? Easily we can run in any machine. Easily we can run in any machine. Let's wait. Let's wait. So you go to Naukri and you search for the jobs on the Docker. You search for the jobs on the Docker. So what they're expecting? DevOps, Kubernetes, Docker. They need a DevOps engineer who can work on Docker and Kubernetes. Okay. So you see how many jobs are available on the Docker? How many jobs are there on the Docker? 26,000 jobs are posted in the Naukri on the Docker. That much important to tool it is. So generally in the market, for the DevOps people, institutes will explain the Docker tool. Not only for the DevOps people, even for the developers also Docker is required. Nowadays in every interview, they are asking questions on the Docker. What is Docker? How do you run your boot application in the Docker? Can you tell me how to write a Docker file? How to create a Docker image? How to create a Docker container? How to check the logs in the Docker container? These questions are very common for the developers in the interview. Especially when you are going for the experienced interview, without asking the Docker's question, your interview will not be completed. It's a damn important tool. Developers also should know Docker. For DevOps people, it is important, as well as for developers also important. Okay. So earlier, 4 years back, 3-4 years back, we did not explain Docker for the developers, but technology changed. Industry is expecting all-rounders. Now, developers also should work on the Docker. 3 years back, only DevOps people used it to work on the Dockers. Now, developers also should work on the Docker. So this is the proof. This is not my website, Naukri, where the Indians will apply for the jobs. So in that Naukri website, many companies posted that they are looking for the DevOps engineers who can work on AWS, Dockers and Kubernetes, Dockers and Kubernetes, Dockers and Kubernetes. So many jobs are available. For Infosys, looking for whom? Dockers and Kubernetes administrator. Okay, so there are many companies which are looking for the developers or DevOps engineers who can work on. IBM looking for a DevOps engineer. Okay, Infosys looking for DevOps engineers, lead DevOps engineer. So many companies posted the jobs in the Naukri regarding Docker. So don't ignore this, guys. This is important for developers as well. Okay, fine. So we understood what is environment. Environment means a platform which is used to run our application. So to run our application, mainly three things are required. Code is required. Developers will write that code. To develop that code, some libraries are required, like Maven library, Spring Boot, JPA security. Code plus libraries not sufficient to run the application. Code is available, libraries are available. Is it sufficient to run the application? No. Some softwares should be installed. The softwares which are required to run the application, those softwares are called dependencies. Earlier, people used to download and install the dependencies to run the application. But nowadays, people are not downloading and installing. People are using Docker to install the dependencies to prepare the environment to run our application. The process of executing our application inside the Docker container is called containerization. It is called containerization. Now, how we are going to containerize our application? When we are going to develop our application, in this application, we are going to write some code. Code will be available. Along with this code, one file will be available, which is called pom.xml. Our source code will be available and pom.xml will be available. Source code that we have developed, pom.xml, which is used to configure Maven dependencies. Along with this, in the project, we are going to create one more file called Docker file. Along with the pom.xml, one more file will be created in the project. That file is called as a Docker file. Are you guys clear with my point? Source code, where our logic will be available. Pom.xml, where our libraries information will be available. Docker file, which contains dependencies information. Once we have project like this, then we are going to compile our source code. We are going to package our source code, then build Docker image. What is that, guys? We need to build Docker image. Docker image means a package. Docker image means a package. Whenever you package your application, jar or var will be created. If your project is a standalone project, whenever you package by using Maven, a jar file or var file will be created. So as of now, we are running the jar var manually by installing all the dependencies. From now onwards, I don't want to run the jar var manually. I want to run my application by using Docker. To run our application by using Docker, we need to build Docker image for the application. To build a Docker image for the application, Docker file is required. To build Docker image for the application, Docker file is required. Inside that Docker file, dependencies information will be available. I mean to say, what softwares are required to run our application. Okay, can you look at the diagram? Excuse me. Now, in our application, code, pom.xml and Docker file will be available. Yeah. So now here in our application, source code is available, pom.xml is available, Docker file is available. Code will be done by development team. Maven will use pom.xml to download the dependencies and Maven package will happen. Now, once the jar or var file is created, I don't want to execute directly. I want to execute that jar file or var file by using Docker container. To execute the project by using Docker container, Docker image should be created. To create a Docker image, Docker file is required. What will be there in the Docker file? Come on. What will be there in the Docker file? Docker file contains dependencies. That means I want Linux operating system to run my application. I want Java 17 version to run my application. I want MySQL database to run my application. I want to Tomcat 9.5 version to run my application. So what are the softwares are required to run the application? Those softwares we are going to configure in the Docker file. Then Docker will download the softwares. Docker will download the softwares and Docker will execute our application by using those softwares. Are you guys clear? Any confusion? Any confusion? What is the difference between pom.xml and Docker file? Pom.xml contains libraries information. Docker file will contain dependencies information. Dependency means softwares that are required to run our application. Okay. Now, what is Docker architecture? What is Docker architecture? So here, for our application, Docker file will be available. For our application one, Docker file will be available. Inside this Docker file, we are going to write dependencies information. What softwares are required. Once the Docker file is available, we are going to create Docker image for our application. We are going to create one Docker image for our application. So to create a Docker image, this Docker file is mandatory. To create a Docker image, Docker file is mandatory. Inside the Docker file, we are going to specify what are the dependencies. This process is called build process. This process is called build process. Docker build means creating Docker image. For every microservice, one Docker image will be created. I mean to say, for every project, one Docker image will be created. Once Docker image is created, we are going to store these Docker images in the Docker Hub. What is that, guys? Docker Hub will be available. Docker Hub is called Docker Registry. Docker Hub is called as Docker Registry. This is called push operation. Whatever the Docker image I have created, I will push my Docker image into Docker Hub. Once the Docker image is pushed into Docker Hub, anybody can pull that image. Once the image is pushed to the Docker Hub, anybody can pull that image. Anybody can run that image also. What is there in this image? In this image, code will be available. Our application libs will be available. Our application dependencies also will be available. We are packaging code plus libraries plus dependencies as one image. It is a package. It is a package. Now, our code is available here. Our code is available here. That code we are going to take, and for that code we are going to use one Docker file. Then when we build, code plus Docker file image will be available. So with this Docker file, image will be created. In this image, what will be available? Code is available, libraries available, plus dependencies are available. So once the image is created, we are pushing that Docker image to Docker Hub. Docker Hub is also called as Docker registry. That is a place where the Docker images will be stored. That is a place where the Docker images will be stored. Once Docker image is available, you can pull that Docker image and you can run that Docker image in any machine. So you can run that image in any machine. I'm taking one dev environment machine. So inside this dev environment machine, I want to run my application. So now for my application, Docker image is already available. Do I need to install the softwares here? Do I need to install the softwares to run the application? Already softwares are part of my image only. Image already created. Inside the image, code is available. Libraries are available. Dependencies also available. So then what will happen? I just need to run this image. I just need to run this image. When I run this image, inside this container will be created. Container will be created. Inside that container, our application will be executed. Are you getting my point? So we need to Dockerize our application. To Dockerize our application, we need to write the Docker file. What is a Docker file? Docker file contains instructions to create the Docker image. What will be there in the Docker image? What will be there in the Docker image, guys? Inside the Docker image, code will be available, libraries will be available, dependencies also will be available. Once the Docker image is available, we are going to store the Docker image in the Docker Hub. What is the meaning of a Docker Hub? That is a place where our Docker images will be stored. Once the Docker images are stored, we can pull the Docker image to any computer and we can run the Docker image. When I run the Docker image, what will happen? Docker container will be created. What will be there inside the container? My application will be executed along with the dependencies. Now, I want to run this application inside SIT environment, another system. I want to run my application in the another system. So what I need to do to run my application in the another system now? What I need to do to run my application in the another system now? You just run the image. Image is already available. You just run the image, then container will be created. Is there any problem? In this machine, Java 1.7 available. In this machine, Java 11 is available. No. Where we will specify which version of Java is required? Docker file. Inside the Docker file, we are going to specify which software is required, which version of the software is required. You no need to worry about that. In this machine, which version of Java available, which version of Angular is available, that's not important for us. Why? Because already in the Docker file, we will specify what dependencies are required for the application. Those dependencies will be downloaded by the Docker when we are creating the image. Inside the image, code, libraries, dependencies will be available. Once the image is available, if you want to use the same image in multiple systems, you store in the Docker Hub. You store your image into Docker Hub. In which machine you want to run it, you download that image and you run that Docker image. When you run the Docker image, Docker container will be created. What is the meaning of a Docker container? In which our application will be executed along with the dependencies. So this is Docker architecture. This is Docker architecture. Let's come here. Now we understood what is Docker. Okay. So Docker is used for creating the container. Container is a box in which our application will be executed. What is the benefit if I execute my application in the Docker container? What is the benefit I'm going to get if I execute my application in the Docker container? It will be taking care of the required dependencies for our application. Okay, good. Now, application architecture. As we discussed, for our application, front end will be available, back end will be available, database will be available. Some projects will go with Oracle database, some projects with MySQL, some projects with MongoDB. Coming to the back end, some projects with Java, some projects with .NET, some projects with Python. Coming to the front end, some projects will use Angular, some projects will use React, some projects will use Vue.js also. Now, when we have this tech stack, installing all the softwares in one system is difficult, right? And that too, in the real time, multiple systems will be available to run our application. Installing all the required dependencies properly in all the systems is a risk process. To avoid that one, we are going to use Docker. And that too, in the real time, application will be executed in the one system? No. So developers has to test it, testers has to test it, client has to sign up, then only it will go for the production rollout. Dev testing, SIT testing, UAT testing, then finally go for the production. When we are testing our application in the multiple environments, multiple systems will be available. So if you are not installing the softwares properly, code which is working in one system may not work in the another system. We are going to get environmental problems. Environmental problems are very common in the industry. Okay, to avoid these environmental problems, we are going to use containerization. What is the concept, guys? Containerization we are going to follow. Now, so if you go for Docker architecture, how we are going to work with the Docker? Docker file will be available. What is a Docker file? Inside the Docker file, we are going to write information related to dependencies required for our application. So we are going to write the dependencies which are required to run our application. Docker file is used to create the Docker image. So if you have a Docker file, by using the Docker file, you can create the Docker image. What will be there in the Docker image? Code, libraries, dependencies. Once the Docker image is created, we will push that Docker image into Docker Hub. Docker Hub is a registry where our Docker images will be available. Once the Docker image is available in the Docker Hub, we can download that image and we can run that image in any system. You no need to bother your system is a Windows system or Linux system or Mac system. Docker can work in any system. Docker can run your application in any system. Docker can download the softwares required for the application and it will execute your application in any type of system. Docker is a containerization tool. What is the meaning of containerization? Package, application plus dependencies plus libraries as a single unit for execution. That is called containerization. Now, when we go for the Docker, we need to understand what is the Docker file, how to create a Docker image, how to store the Docker image in the Docker Hub, then how to create a Docker container. That concept we have to understand. So before going to do that, are you guys clear with the Docker architecture? Yes, right. So let's write definition for the Docker. So Docker. Here, when we are, the biggest challenge is when we are explaining DevOps demo session, Java project demo session, I will tell that we are going to cover Docker in the course. First day they will ask, sir, what is Docker? I will tell Docker is a containerization software. Sir, what is containerization? So in the day one, will you understand that? It is taking almost 1 hour to understand what is Docker. It is taking 1 hour to understand what is Docker. Okay. Now you got the clarity. What is the Docker? Why to go for Docker? Now next step, how to work with Docker. Once you complete that, then you can keep Docker in your resume. I know how to execute my application by using Docker. So 3 years back, DevOps people will keep Docker in the resume. Now developers also keeping Docker in the resume, because you should know how your project is getting executed as a container. Earlier, 3 years back, 4 years back, developers will not work with the Docker. DevOps people will set up the Docker. DevOps people will write the Docker file for the project. Now, developers only writing the Docker file. In the interview, they will ask, can you tell me how to write a Docker file for the Java application? Normal Java without Spring Boot. How to write a Docker file for the normal Java application execution? How to write a Docker file for Spring Boot application execution? So if you are attending as a DevOps engineer, how to write a Docker file for Python application also. So by using Docker, you can execute any type of application. Java, Python, Angular, React, Node, PHP, any type of project can be executed by using this Docker software. Are you guys clear with my point? Yes, good. So some people are asking about project batch here. Guys, the announcement. So from 21st of this month, from next, what is that? Wednesday, I think so. Yeah, Wednesday only, na? Yeah. From Wednesday onwards, we are starting new Java real-time project batch at morning 7:30 a.m. Okay. Online people, you can see my new batches schedule. My new real-time project batch is starting from 21st February at 7:30 a.m. IST. My Spring Boot microservice batch is starting from same date at 9:30 a.m. IST. My Java full stack development will start from 22nd February at 11 a.m. From full stack means from the basic, from the core Java level, I'm going to take the session. So if you have any friends, you can forward this information to them. Okay, good. Yeah, real-time project from Wednesday at 7:30 a.m. Boot microservice from 9:30 a.m. Java full stack at 11 a.m. Both classroom for all three batches. Classroom training and online training is available. So these three batches I'm going to handle for this now. Yeah, good. Okay, now let's understand what is Docker. Can anyone tell me what is the Docker now? What is Docker? Docker is a containerization software. Docker is a containerization software. What is the purpose of this Docker? What is the purpose of this Docker? Docker is a containerization software. But what is the benefit? Docker is used to simplify our application deployment process. Basically, our application execution process, our application deployment process. Docker will take care of required dependencies of our application. So Docker will take care of required dependencies of our application. Using Docker, we are going to run the application in the container. Using Docker, we will run our application as a container. By using Docker, we will run our application as a container. What is a containerization now? What is a containerization? Come on, guys. What is a containerization? Come on. What is the definition for containerization? Running our application as a Docker container. The process of containerization, nothing but the process of packaging and executing our application inside container. Inside container is called as containerization. The process of packaging our application code and dependencies as single unit and executing inside a container is called containerization. Can you read what is containerization? The process of packaging our application code plus dependencies as a single unit and executing inside a container is called as containerization. Container is a box. Container is a box. In the real time, container we will call as a container is a virtual machine. Container is an virtual machine. Virtual machine means one computer. We cannot see that computer with our eyes, but that is one machine with operating system. So internally, every Docker container is a Linux machine. Whenever you run the Docker image, as we have seen in the architecture, when we run the, where is that man? Whenever you run the Docker image, I'm saying container is creating, right? That container is a Linux machine. That container is a Linux machine. That means inside the Linux, Docker will download all the softwares required and it will run our application in the Linux machine. That is called container. Containerization, nothing but the process of packaging our application code plus dependencies as a single unit and executing inside the executing as a container. Executing as a container is called containerization. What is the meaning of container? Container is an virtual machine. 99.999% of the times, this is a Linux virtual machine. Docker container is a Linux virtual machine. Are you able to follow this? Is this clear for all of you? Yes, tell me, what is a Docker? What is a Docker? Docker is a containerization software. Docker is a containerization software. Docker is used to simplify our application deployment process. How Docker is simplifying our application deployment process? How it is simplifying application deployment process, guys? It is downloading the required dependencies for our application. Docker will take care of required dependencies of our application. Using Docker, we will run our application as a container. What is a container? Container is a virtual machine. Container is a virtual machine. That virtual machine is a Linux machine. Inside the Linux machine, our application is going to execute, guys. Inside the Linux machine, our application is going to execute. Good. Now, in the real time, one project will contain multiple microservices. For example, my project is having 30 microservices. Then what will happen? When my project is having 30 microservices, then what will happen? We are going to create 30 Docker files. For every microservice, one Docker file is required. For every microservice, one Docker file is required. And here you need to understand that we are creating Docker container. Currently, we will create a Docker container manually. If you run the Docker image, Docker container will be created. If you run the image, container will be created. That is manual process. Now, in the real time, we don't create the containers manually. We will go for Kubernetes. What is that, guys? Kubernetes. Kubernetes is called orchestration platform. Docker is a containerization platform. Kubernetes is an orchestration platform. If you use Docker, you will create a Docker image and you can create the container also. But every time create the container, delete the container, increase the count of the containers, decrease the count of the containers, load balancing for the containers will be taken care by Kubernetes software. Docker plus Kubernetes is the excellent combination for the Java developers. Java, Spring Boot, Docker, Kubernetes plus Jenkins, you are a hot cake in the market. If you know this Docker, Kubernetes plus Jenkins, 60% of the DevOps you know. 60% of the DevOps also you know. Because DevOps engineers are going to work with Docker, Kubernetes, Jenkins, Git, Maven. Already we know Git and Maven. Now we are learning Docker. In future, we will learn Kubernetes plus Jenkins also. You are called Java with DevOps knowledge. If you know this Docker, Kubernetes, Jenkins, you know 50 to 60% of the DevOps operations also. Are you getting my point? Extra thing for the DevOps people, infrastructure creation by using Terraform, that is not required for the developer. Terraform is used to create the servers. Machines we are creating manually, right? That thing will be taken care by Terraform. If you know the Terraform, you are also a DevOps engineer. So nowadays, every Java developer should know DevOps operation. Not only Java developer, every developer should know coding plus operations also. This is called one operation. Creating a Docker file, creating a Docker image, storing the Docker image into Docker Hub, and creating the Docker container by using Docker image, managing the containers by using Kubernetes. These are called operations in the project. Development plus operations is called DevOps. If you know development plus operations, then full stack developer with DevOps and AWS knowledge. That is expecting from the companies. Companies are expecting that from the people. Are you clear? Good. So what is the purpose of Kubernetes? It is used to manage the containers. We are creating container manually, but in the real time, manually we don't create the containers. To create the containers, that means to run the Docker image, we will use Kubernetes in the real time. Are you getting my point? Good. So here we are understanding the process of packaging our application code and application dependencies is called as containerization. Containerization, nothing but executing our application inside a box. Executing application inside the box. So now, in order to containerize our application, first we need to set up Docker software. We need to set up Docker software. Now, I will take one machine. In this machine, one operating system will be available. It can be for every machine, operating system is mandatory. I will take one machine. In that one operating system will be available. This operating system is called as a host operating system, which is our main operating system. So for every machine, one operating system will be available. That is called our main operating system. That is called as our main operating system. Now, in this system, I'm going to install Docker engine. That is called Docker software. I'm going to install Docker software in this machine. Once a Docker software is installed in this machine, now we can run multiple containers in our machine. Multiple containers we can run in our machine. So this is container 1. We can call it as a C1. This is container 2, C2, and container 3, which is C3. Like this, in one machine, we can create multiple containers. When I say container, every container is a separate machine. This is one Linux machine. This is one Linux machine. This is one Linux. That means that in my machine, I will install the Docker. By using the Docker, I will create a Docker container. When I create a Docker container, again it will create one more machine. The machines which are created are called as Docker container. Docker container is a machine only. That is a Linux virtual machine. We cannot see that machine, but we can access our application which is running in those machines. Now, where my application is executing? Application is executing in my machine, or application is executing inside the container. Now, my computer don't have Java. My computer don't have Angular. Don't have MySQL also. But I'm running my application because my application executing in the container. Container is a Linux machine. In that machine, softwares will be installed. Now there is no relation between my machine and the container machine. Container machine is a different. This is called virtualization. Running one operating system in the another operating system is called virtualization. Now, if you want to access the application running in the container, we need to establish link between container and our operating system. Then only by using this operating system, we can access the application. We need to establish link between, we need to, a simple example, sir. This is one room. This is one room. When we have taken this building, this is one room. In that room, I have done some partitions. For every partition, there is a door. Why the door is available? For accessing that room. Suppose when I do the partition, if I don't keep this door, nobody can come in and out. So similarly, so now my machine is one big room. In that room, small containers are created. Every container is one small room. Now I want to go into container. If I want to go into container, some link is required. If I want to go inside another room, the door is required. Similarly, in my machine, other machines are created. Now from my machine, I want to enter into those machines. That is called port mapping in the Docker. What is that, guys? Port mapping. So we need to map container port to host port. Then we can access our application. Otherwise, we cannot access our application. Container port, we need to map to host port. Then only our application can be accessed. Otherwise, our application cannot be accessed. Are you able to follow this? So now what is a container? Can you tell me what is a container? What is a container? That is a virtual machine. What will be there in the container? Come on. What will be there in the container? Inside the container? Inside the container? Inside the container, dependencies plus libraries plus code will be available. So whenever you run any application by using Docker, you need to understand host machine. In the host machine, Docker will be installed. By using the Docker, container will be created. Inside the container, application will execute. Our container is another Linux machine. You got the clarity? Yes. Now, let us set up a machine with the Docker software. Then we can practice Docker. We can work with the Docker once the Docker is installed in our system. Docker can be installed in the Windows machine as well as in the Linux machine also. You can install the Docker in the Windows as well as in the Linux also. I'm going to install Docker in the Linux. I'm going to install the Docker in the Linux because Windows nobody will use in the real time. In the real time, complete operations will happen on the Linux machines only. Okay, so let me log in into my AWS cloud account. In this AWS cloud, I will create one Linux machine. In that Linux machine, I will install my Docker software. Okay. Yes, I logged in into my AWS cloud account. Let me go to one service called EC2 service, launch one instance. Sir, how to install the Docker? I have given one document, guys. So DevOps documents available in my Git repository. Here, Docker setup I have given. Go to Linux machine and execute these commands in the Linux machine. Then Docker will be installed in the Linux machine. Go to this AWS cloud account, launch instance, give the name for the machine. I'm giving this as Docker server. You can give any name. I'm giving the machine name as Docker server. Then Amazon Linux machine I'm creating. T2 micro I'm using, which is free tier eligible. Key pair, whatever the key pair you want, create a key pair. I'm using my key pair name as Docker workshop. You can give any name. With this name, one PEM file will be created. PEM file will be downloaded. Click on create key pair. You can see Docker workshop PEM file is downloaded and it is selected. Okay. Then that's it. You see, I logged in into AWS. I'm creating one Linux machine in the AWS, Amazon Linux, T2 micro, key pair I created. Then I will go and click on launch instance. So with this, my Linux machine is created. In this Linux machine, I need to install the Docker software. Okay. For this, let me connect with this Linux machine. By using mobile extram, I'm going to connect with the Linux machine. Go to mobile extram software. I'm using Windows machine. From the Windows, I'm connecting to Linux machine. Go to the session, SSH session. Then copy the public IP. Copy the public IP of the machine. Username of the machine, which is EC2-user. Private key, the PEM file we downloaded, Docker workshop PEM file, click on OK. So with this, my Linux machine is ready. I'm using my Windows system to take the class, but operations I'm doing on the Linux machine. Okay. So once you go to Linux machine, you can check who am I. I logged in into this machine as a EC2 user. In this machine, you verify Java is available, Java is not available. You verify Docker is available, not available. Now, I want to install Docker in this machine. I want to install Docker in this machine. Why we need to install Docker in this machine? To run Docker containers. So we will install the Docker software to run the Docker containers. Okay. Project people. For Sonar, we used Docker. For Nexus also, we used Docker. Now we are installing the Docker to understand what is Docker. Good. So in the project class, we executed Sonar server as a Docker container. We executed Nexus server as a Docker container. Okay. Now go to here. These are the commands. I created Linux machine by using AWS. I connected to the Linux machine by using mobile extram. These are the commands which are used to install the Docker software in the Linux machine. Just to copy this one, I will give this link, guys. Copy this and paste it. Okay. It is going to download and install Docker software in my Linux machine. Okay, good. See this? Docker is getting downloaded and Docker is installed. I have quit the terminal, press R. My terminal will be restarted. Yes, terminal is restarted. Now verify Docker-V. So earlier Docker was not available. Now Docker is available. To verify that Docker is working or not, you can use a command called Docker info. When you use the Docker info, if you are getting this information, that means Docker is running successfully in our system. So with this, I have a Linux machine. In my Linux machine, Docker server is ready. In my Linux machine, Docker server is ready. Now, you see the Docker architecture. What is the Docker architecture, guys? Docker file. What is a Docker file? Which is used to create the image. What is a image? It is a package. Code plus libraries plus dependencies will be available. What is the Docker Hub? What is the Docker Hub? The place where we are going to store the Docker images. Then what is a container? Container is a place where our application is going to execute. Container is a place where our application is going to execute. Now, so here in my machine, in my Linux machine, Docker is running. First, let me verify. Do we have any Docker images in this machine? Image means a package which contain code plus dependencies. Docker images. Do I have any images in the system? No, images are not available. So we need to create the image. How to create an image? By using Docker file. If you have the Docker file, using that Docker file, you can create the Docker image. Now I am using a command called Docker images command. When I use the Docker images command, I'm not getting any output. That means the Docker images are not available. Okay, you can use some ready-made Docker images, guys. The public Docker images will be available. For that, you can go to Docker Hub. Where you can find the Docker images? Docker images you can find in the Docker Hub. So Docker Hub is called Docker Registry. Docker Hub is called Docker Registry. So sign in into your Docker Hub. If you don't have an account, you can create your account in the Docker Hub. Let me log in into my Docker Hub account. I'm trying to log in into my Docker Hub account. Yes, I logged in into my Docker Hub account. So you can see my Docker images are available as a public images. You can see there is one Docker image I uploaded 2 years back. How many people downloaded? 68,000 people downloaded our Docker image. So that is a Spring Boot application Docker image. So if you want to run the Spring Boot application, you can simply download the Docker image and you can run your Docker image. So if you don't know, we are initial step now, we don't know how to write the Docker file. Tomorrow we are going to learn how to write the Docker file, how to create a Docker image, how to store the Docker image in the Docker Hub. Today I will show you how to download the existing Docker images, how to run the Docker image to run our application. Got it? So here in my system, Docker is installed. I'm executing a command called Docker images command. Do I have any images now? I don't have any images. So if you want to download a Docker image, the command is Docker pull. Docker pull is used to download the Docker image. There is a default image called hello world image is available. Docker pull hello world. So that there is an image in the Docker Hub with a name called hello world. Sir, how can we search the Docker images in the Docker Hub? Here, search option is available. You go to this search option and you search for a image with a name called hello world. So when you click on this, what is the command they are giving now? Docker pull hello world. What is the meaning of that? Download hello world Docker image. What is a Docker image? A package which contains code plus dependencies. Now you can execute this command Docker pull hello world. It is downloading Docker image from the Docker Hub. So hello world image is available in the Docker Hub. It downloaded that Docker image. When it downloaded that image, you can verify Docker images. Earlier, when I executed Docker images, what is the output I'm getting? Nothing. Now when I executed Docker images, what is the output I'm getting? Hello world. What is the image name? Hello world. For image, ID is also available. So tell me, we discussed about two commands now. What is the purpose of Docker images command? To display available Docker images. To display available Docker images. Now I am using Docker pull image name. What is the meaning of Docker pull image name? Download Docker image. If you want to run the image, Docker run image name. If you run the Docker image, Docker container will be created. Creating Docker container. Creating Docker container. Pull is used to download the image. Run is used to run the image. I have already downloaded Docker hello world image. Now I want to run that image. Docker run. Whenever you are running, you can use image name or you can use image ID also. Let me use image ID, execute it. Yes, we are getting hello from the Docker. That means Docker is running successfully. Docker container is created. In that container, hello world message is available. In our application, hello world message available. That hello world message printed on the terminal. Can you read these points now? When I executed Docker run image ID, I got this output. Can you read this one? All of you, please. Complete. People who are watching in the YouTube, please like this video, like and subscribe. Share. Like, share and subscribe. You understood what it is saying, guys? If you are seeing hello from Docker, that means Docker installation is successful and you are able to run the Docker image. That means container is created. How that container is created? Whenever we execute this command, Docker client is available, which contacted a Docker daemon. Docker daemon is a background thread in the Docker server. That a Docker daemon downloaded that image and executed that image. Container created, container giving some output. That output is printing on the terminal. Are you guys clear with this? Good. So how to check all the images which are available in our machine? Docker images command. What is the meaning of images? What is the meaning of images? Images means the packages which contains code plus dependencies. Okay. Next one, how to download a Docker image? How to download a Docker image? Docker pull image name. What is the image name I'm using now? Hello world image I'm using. Docker pull hello world. My Docker image is downloaded. Then how to run the Docker image? Docker run image name or image ID, anything. So with this, we are able to get the output from the Docker container, which is saying hello Docker. That means our setup is a success. Our Docker server is working successfully. Are you clear? Now, I want to run one Java application inside the Docker container. Okay. So if you want to run your application in the Docker container, Docker image is mandatory. If you want to run any application by using Docker, Docker image is required. So currently, we don't know how to create the images. To create the images, what is required? Docker file is required. If you want to create a Docker image, Docker file is required. Tomorrow, we are going to learn how to write the Docker files. If you know how to write the Docker file, then we can create the Docker image. That image we can store in the Docker hub also. But today what I am doing, I'm downloading my existing Docker images and I want to run those images. Okay, go to our Docker hub account. You can also create one Docker hub account. It is a free of cost only, just to store your images. So go to Docker hub. Here, my image is available, which is Ashok IT Spring Boot REST API is available. So already these many people downloaded my image because it is a public image. If you want nobody to download your image, make it as a private. Nobody can download that. Okay. Now click on this image. When I click on this image, they are giving a command. They are giving a command. If you want to push, then this is the image, public view, then this is the command. They're telling what is the command I need to use to download the image also. Docker pull Ashok IT / Spring Boot REST API. Copy this one. So you can see the command here. This is the command to pull my Docker image. This is my image name. This is my image name. I want to pull it. So here in the Docker, the advantage is you, instead of pulling, you can directly run also. Pull is not mandatory here. Directly I can run also. When I run directly, it will check in this machine Docker image available or not with this name. With this name, if image available locally, it will run that. If image not available, it will download and it will run that. It will download and it will run that image here. Are you guys able to follow this? Yeah. Let me take this image now and let me pull this image or directly run this image. Docker run my image name. So before running, you check in my system, Java is available. In my system, Java software is available. No. Without Java, can you run the Spring Boot application? No. But that Spring Boot application will run in this machine or it will run in the container machine. Container machine. Inside the container, Java will be installed. Who will install the Java in the container? Docker engine. Docker is going to install in the container. In that container, my Spring Boot application will be executed. So here what I am trying to do is, we have already taken one Linux machine, guys. In the AWS cloud, I have taken one Linux machine. This is Linux OS. This is my Linux OS. Can I call it as a host? The main machine, which is our host machine. Inside this host machine, now I install Docker software. Inside the host machine, I install Docker software. By using this Docker, I am going to run my application as a container. I will run my application as a container. This application will run inside a container. That container will run on the port number 8080. This is a container port number. So whatever the port number is available, right? This port number 8080 is a container port number. This container, this is a another machine, guys. This container is a another machine. Now, let me take this. This container is a another machine. 1 minute. This is a container. Inside this container, my application is running. So in this diagram, how many machines are available? How many machines are available now? 2 machines are available. One is host machine. Another one is a container machine. Application is running in which machine? Container machine, not on the host machine. Where the Java will be installed now? Container machine. Who will install the Java in the container? Docker is going to install Java in the container machine. But can I access that application? Can I access that application? No. Why? It is not on my host machine. It is available in the container machine. So what we need to do? What we need to do? We need to perform port mapping. What we need to do, guys? We need to perform port mapping. So we need to specify -p is used for port mapping. My container port is 80, host port is 8080, container port is 8080. That is called port mapping. Inside the container, application is running on the port number 8080. Map that port number to host port number. My Linux machine is having one public IP address. Now, to access our application, public IP colon host port /URL. Like this, we are going to access our application. Are you able to follow me? So I have my Linux machine, which is a host machine. In that host machine, I installed my Docker software. By using that Docker, I downloaded one Docker image from the Docker Hub. I'm going to run the Docker image. When I run the Docker image, Docker container will be created. Container is a Linux machine. Inside the container, my application will be executed. So if you want to access your application in the browser, port mapping is required for the application. How do we do that port mapping? -p host port colon container port we need to do. Then only application is accessible. Otherwise, application is not accessible. Now, you see, guys, the Java project people, when we install SonarQube server as a Docker container, what we have done? Now you will understand Sonar setup. You see the command, blindly we executed that command at that time. What is this one? Docker run -p 9000:9000. That is port mapping. That is port mapping. We installed Nexus server by using Docker in our project batch. Okay. So in the Nexus server, we installed Docker. What is this one? Can you read this one now? Docker run -p port mapping. Name for the container. This is the Docker image. Nexus server we executed as a Docker container. SonarQube server we executed as a Docker container. Now Spring Boot application we are going to execute as a Docker container. Where these images available? In the Docker Hub. My Spring Boot application is having a Docker image. that Docker image available in the Docker Hub. 2 years back, I stored that image in the Docker Hub. Approximately 70,000 people downloaded that image. So once the image is available as a public, anybody can download that image to run the application. Are you able to follow this? Now, I want to run Jenkins server. I want to run Jenkins server. Jenkins also you can run by using Docker. You no need to install Jenkins manually in the system. If you have Docker, you can ask Docker to download your Jenkins. Go to Jenkins. Now see how many people downloaded that Jenkins image. How many pulls? 1 billion, not million. 1 billion people downloaded Jenkins by using Docker. Okay, Docker is that much famous in the market. If you want to run any server, like now, I want to run MySQL database. You no need to install MySQL database manually. You can ask Docker to run the MySQL database. I want to run Tomcat server. Ask Docker to run the Tomcat. Sonar Cube, Nexus server, Jenkins server. All these things can be executed as a Docker container. You no need to download and install the software. You can use the Docker to run the required softwares. Are you able to follow this? Good. Now, let's go and execute my application. Okay. Clear this one. Think it is disconnected. Duplicate tab. Yeah. Clear this. Go here. Docker images. Already there is one image available with a name called hello world. I want to delete that image. Docker RMI. RMI is used to remove the image, but it is not getting deleted. Docker is not deleting because this Docker image associated with a stopped Docker container. First, I need to delete the container. To delete the container, Docker RM container ID. Docker RM container ID, RMI image ID. Still one more container is available. 2 times I executed, 2 containers created. Yeah, no such image. Docker images. I'm seeing all the images available. I want to remove the image. RMI image ID, not deleting because it is associated with one stopped container. Docker RM container ID. First delete the container, then delete the image. Docker images, Docker RMI image ID. Okay. Now that image is deleted. If your image is associated with any container, it cannot be deleted. First you delete the container, then you can delete the image. I have deleted that image now. Now you check Docker images. Any image available? No. I want to download the image to run the image. So downloading is mandatory or directly we can run. If you run directly, first it will check in the local that image available or not. If not available, it will download and it will run that image. Can we run the image now? My Spring Boot application can we run? Yeah. What is the image name? Ashok IT / Spring Boot REST API. So if you run this, can you access directly? No. You need to do the port mapping. How to do the port mapping? -p 8080:8080. First of all, let me check what is my container port number. I'm not sure what is my container port. In the Spring Boot, maybe I have changed the port number. I don't know. First, let me run this directly without port mapping. It will print the port number. Then we can map that port number. Docker run my image name. Execute. What is this one? Unable to find this image locally. Then what it is doing? Downloading image. After downloading, banner. That means boot application is getting started. Our Spring Boot application is getting started. What is the port number I used? 9090 server.port. In the Spring Boot YML file, I changed the port number from 8080 to 9090. Now I need to map it accordingly. So this application is running on the port number 9090. Now I need to do the mapping -p 9090:9090. This is my container port number This is my host port number. Container port number and host port number is available. Are you able to follow this? The next one, whenever you run your application, your console is blocked, guys. You can't execute any other command because your terminal is in the open state. Your terminal is in the open state. Control C, then the container will be stopped. I pressed Control C, container is stopped. Now I want to create the container and my terminal should be available to execute the next command. For this, we need to create the container in the detached mode. For that, we will use -d. Without -d also you can run, but you can't execute any other command in the console. If you use -d, then terminal will be open to execute the other command. -d represents detached mode. -d represents detached mode. -p represents port mapping. Okay, good. Let's take this one. Docker run -d. What is the meaning of -d? Detached mode. -p port mapping. Container port 9090. Host port 9090. What is this one? My Docker image. Yeah, take this Docker image. Yeah, clear the console, then run this Docker image. Docker run -d -p 9090 colon 9090 Ashok IT / Spring Boot REST API. Enter. Yeah, what happened? Container is created. What about the terminal? I can execute next command in the terminal. Whether your container is created or not, you can verify using Docker PS. Docker PS is a command to display all the running Docker containers in the machine. Docker images, to display the images available. Docker PS will display all the running containers in the machine. Are you clear with my point? So what is the difference between Docker images command and Docker PS command? Images command will display what are the images available in our machine. Docker PS command will display what are the containers running in our machine. Is this clear? There is one container which is running. This is a container ID. 15 seconds ago this is started. This container is mapped to port number 9090. Now to access this application, I need to do a small setting in the AWS. Security setting I have to enable. For this machine, one security group is available. Go to that security group, edit that security group, edit the inbound rule, then enable port number. What is our port number? 9090. Allow the traffic which is coming to 9090. For this machine, AWS provided a security group. It will not allow the traffic. To allow the traffic, I'm enabling one inbound rule in the security group with the 9090. Save it. So with this, I'm able to enable the security setting. Now, take this machine public IP now to access our application. Take this machine public IP, copy this public IP colon 9090/welcome/Ashok. Yes. So whatever the name, this is my method URL pattern. This is path parameter. Welcome Ashok. If I give, it is giving the response as welcome to Ashok IT. Where is this? 9090/welcome Ashok. I'm getting the response as welcome to Ashok IT. If I give the different name as Raju, then it is giving the response as Raju, welcome to Ashok IT. Where my application is running now? Inside the container. Now anybody can access my application with that public URL. You can type in your mobile that URL public IP colon 9090/welcome/your name. Then that REST API will give the response. So that is my Spring Boot REST API which is executing in the Docker container. In this process, did I install Java software? No, I have not installed my Java software. It is taken care by Docker. Taken care by Docker. Good. So you understand how to run the Docker image? Yes. What are the commands we have seen now? We have seen one command called Docker images command. What is the meaning of Docker images command? Which is used to display available Docker images. What is the purpose of Docker pull command? To download Docker image. What is the purpose of Docker run command? To create Docker container. Docker container. Docker PS. What is the purpose of Docker PS? Display running Docker containers. Display running Docker containers. Now, if you want to see stopped containers also, PS-A, display running plus stopped containers also. Now, Docker RMI image ID. What is the purpose of RMI image ID? To delete Docker image. Then Docker RM container ID. Docker RM container ID to delete Docker, to delete stopped Docker container. If the container is stopped, then only you can delete. To delete stopped Docker container. If the container is running, directly you cannot remove that. First you need to stop, then you need to remove. How to stop the Docker container? Docker stop container ID. It is used to stop the Docker container. To stop Docker running container. If container is running, then you can stop running container. If you want to start the stopped container, Docker start container ID will be available. Okay, to start the container. Already container started and we stopped it. Again, I want to restart the same container. To start stopped container, we can use Docker start command. So read these commands now. What is the first command? Docker images. What is the purpose of Docker images? To display available Docker images. What is the Docker pull? To download Docker image. What is the Docker run? To create the Docker container. What is the Docker PS? To display running Docker container. Docker PS-A to display running plus stopped containers. Docker RMI to delete Docker image. Docker RM to delete stopped Docker container. Docker stop to stop running container. Docker start to start stopped container. Are you able to follow this? Yeah. Next one, there is a command called Docker system prune -a. So to delete unused images, plus stopped containers at a time. So there are several unused images available and there are stopped containers also available. I want to clean up the system. To clean up the system, Docker system prune -a, which is going to delete all unused Docker images and stopped Docker containers. Clear? Now go and execute this command. Docker system. Where? Yeah. My mobile extreme terminated. Yes. So what is the command? Docker images. There is only one image available. Docker pull hello world. I am pulling another image. Docker pull hello world. I am pulling another image. Now you check it. Docker images. How many images available? Two images. Docker PS-A. What is the meaning of PS-A? One container is in the running status, another container is in the stopped state. One unused image available, one stopped container is available. I want to clean them. How to clean them? What is the command? Docker system prune -a. Warning is coming. This will remove all stopped containers, unused networks, unused images, and cache. Yes, delete them. Okay. So with this, we are able to clear the system. All the unused images, stopped containers are deleted. Now check it once again. Docker images. Only our image is available. Docker PS-A. There is only one running container is available. I want to stop this container. How to stop this container? Docker stop command. Docker stop. What is this ID? Container ID. Yes, the container is stop. Check it. Docker ps-a. What is this? Exited. It created 8 minutes ago. Now it is exited. It stopped 5 seconds ago. Now, can I restart the same container? Yes. How? How to restart the same container? Docker start container ID so that the container will be restarted. I want to delete the container. How? Docker rm container ID to delete the container. Are you clear? Very good. So I hope you got the clarity. What is the Docker and how to work with the Docker. Here, what is the meaning of -d? -d represents detached mode. Terminal will be available for executing the next commands. Okay. The next one, what is -p? -p represents port mapping. Port mapping is mandatory. If you don't do the port mapping, then what is the problem? You cannot access our application outside. You can't access the application outside. And now let's go here. My container is available. Docker ps-a is available. Let me remove this. Docker rm container ID, which is stopped container, deleted. Now Docker ps. Any running container? No. Any stopped container? No. Docker images. My image is available. I want to run the container again. Can you tell me the command? Can you tell me the command? Docker start a run. If you want to execute start, container ID is required, right? Container ID is available or not available? That is deleted. Na? We need to create the new container. How to create the new container? Docker run image name or image ID. Okay. Docker run image name or image ID. So take this command. Docker run -d -p image name I am giving. Execute. So with this my container is created. What is the meaning of container? What is the meaning of container? Virtual machine. Inside that my code will be executing. So for that I am doing the port mapping also. -p 9090:9090. Clear the console. Check it. Docker ps. Container is running or not running? Container is running. Is this clear? Good. So when the container is running, I can access my application. I'm able to access my application. For online people, I'm giving the URL. You can also access that. You can click on that URL. You can access that. When the online people are accessing the URL, I want to see logs of my application. I want to see the logs of the application. What is the command? Docker logs. What the Docker logs is expecting? Container ID. Docker logs container ID. This is the question in the interview. How do you check the container logs? Your application is executing inside a Docker container. How do you check the logs of your Docker container? There is a command. Docker logs space container ID. Enter. Now you see those many requests are coming to my application. So people are accessing my application. In my application, welcome REST controller available. Welcome message execution start. Welcome message execution end. Loggers I have implemented in my app. See, these many requests are coming to our application. We are able to see the logs of our container also. How we are checking logs of our container? By using which command? By using a command called Docker logs command. Okay. So here we can use Docker logs. What is the input? Container ID to see container logs. To see container logs. In one machine, multiple containers can execute. Which container logs you want to check? That container ID you need to pass. In the real time, if you have 20 microservices, for every microservice, a container will be created. Every microservice will execute inside a container. And one microservice will execute in multiple containers also. Those are called instances. In the Spring Boot microservices, we have seen instances of our welcome API. One instance means one container. I want to create 10 instances for my application for the load balancing. So we are going to create 10 containers for the same Docker image. Why we will create 10 containers for the same Docker image? Load balancing. One container means one application running in one server. Same application I will run in the another server by creating another container. So one image can have multiple containers also. Every container is a Linux machine. So in the real time, are we going to create the containers manually? Who will create the containers in the real time? Kubernetes. Kubernetes is called orchestration platform, which is used to manage the containers. Which is used to manage the containers. Are you able to follow this? You understand how to work with this? Yeah. So today, what we learned, I hope the 2.5 hours of time you spent for this workshop is useful for you. Useful or boring? Huh. Tomorrow also continuation class available. Tomorrow morning at 7:30 a.m. we have the class for the Docker continuation. So tomorrow we are going to learn how to write a Docker file, how to create our own Docker image, how to push the Docker image into Docker Hub, and what is the Docker Compose. Okay, so 4 topics are there. Tomorrow another 1.5 hour session will be there on the Docker. Got it? Tomorrow morning, let's take at 8 a.m. Tomorrow morning we'll meet at 8 a.m. 8 to 10, the class will continue for the Docker. Okay. Now, so today, what we learned, guys, can you summarize quickly? We discussed about what is Docker. What is Docker? Docker is a containerization software. What is containerization? What is containerization? The process of packaging our application and dependencies as a single unit for the process of executing our application inside the container is called as a containerization. What is the benefit with the containerization? Advantages with the containerization? The application deployment process will be simplified. Application can be executed in the any machine without bothering about the infrastructure. Without bothering about the softwares, our application can be executed in any machine. Those are the advantages with the containerization. Then we discussed about Docker architecture. What is the Docker architecture? Docker file, Docker image, Docker hub, Docker container. What is a Docker file? It contains the instructions to build the Docker image. Tomorrow we will see how to write the Docker file. What is a Docker image? Image is a package which contains code plus libraries plus dependencies. What is Docker hub? Where we are going to store the Docker images. It can be a public image or private. Public means anybody can pull and can run. Private means only we can pull and run that image. Okay. Then Docker container. When you run the Docker image, container will be created. Docker setup. This Docker setup I have done by using Amazon Linux machine. I'm giving my GitHub repository link here for the Docker setup, guys. So this is the link. Sorry, not this. Docker setup. This is my Git repository document. So just to follow these steps, you can set up Docker in your Linux machine. Docker setup. Then we discussed about Docker commands. We discussed about Docker commands. What commands we learned? Docker images, Docker pull, Docker run, Docker logs, Docker ps, Docker ps-a, Docker RMI, Docker RM, Docker system prune, stop, start, logs, like that several commands we have seen. When we are running Docker container, it's important to understand what is detached mode and what is port mapping. What is the detached mode? What is the detached mode, guys? What is the detached mode? To run the container in the detached mode. Why we need to run in the detached mode? To execute another commands. Once the container is started in the detached mode, then you can execute other commands. If you don't execute the container in the detached mode, other command cannot be executed. What is the purpose of a port mapping? What is the purpose of port mapping? To access our application by using host machine. Application running in the container machine, to access by using host machine, port mapping is required. Port mapping is required. Okay, good. So Spring Boot REST API we executed by using Docker. This is my official public REST API. You can pull this and you can execute this REST API. So here the URL pattern for my application, http:// public IP colon port number, whatever the port you are giving, /welcome /some name you can give in order to access that URL. Today, please practice that. If you practice these commands today, then only tomorrow's session will be understandable for you. If you don't practice today, tomorrow lot of confusion will be there. So please set up the Docker in the Linux machine and practice the commands that we discussed in the class. So you will enjoy the tomorrow session. You will write the Docker file. You will create your own Docker image. You will push your Docker image to Docker Hub. Then you can Dockerize your microservice. Got it? By using Docker, we can execute Java application, .NET application, Python, React, PHP, Node.js. Any type of application can be executed as a Docker container. Good. Fine. Offline students, any questions, anyone? Offline students having any questions? Anybody having any questions, guys? Manually people use it to do. Before the Docker, people use it to install all the softwares they need to deploy manually. That's why Docker became very popular in the market. Yeah. Next question. Offline students, any question? Currently for the containerization, no. For Kubernetes, alternate is there, but for the Docker, there is no alternate. What is the difference between Docker and Kubernetes, guys? Docker is a containerization tool. Kubernetes is an orchestration tool. What is the meaning of orchestration? Managing the containers, create, delete, scale, increase, decrease, such kind of management operations will be taken care by Kubernetes. Clear? Good. Fine. So with this, I'm stopping for today. I will share this video and I will share these notes also. I request all of you, please practice today itself, because tomorrow morning at 8 o'clock only we have the next class, continuation class for the Docker. If you don't practice today topic, you will not understand the tomorrow topic. So it will take a hardly 15 to 20 minutes of time to do the practice. Just 30 minutes more than sufficient for practice 10 commands. That's it. Fine, guys. Good. Thank you. The people who are watching in YouTube, thank you.